Today on Blueprint Bootcamp, we're going to be looking at things from a whole different perspective, looking at stuff from an isometric view, so stay tuned. So for today on BB number 4, we're going to be looking at what's called our Fit-Up Jig. So if we take a look over at our drawing, BB number 4 is going to be a 3D part. And this is one I found in an old book that I had lying around. And this is kind of how they had the dimensions, and they're kind of awkward and hard to look at. Technically, all these dimensions are wrong. I haven't quite figured out how to do the isometric dimensioning when it comes to drawing. So if somebody knows how to do that to where they actually align correctly, all of these numbers I had to edit to make it match what was actually in there. But it doesn't change how you draw this. So if somebody in the comments knows how to do isometric dimensions, let me know. That would totally help me out. But there's still enough here that we can actually draw it. So basically our game plan here, if I take this, we're going to kind of split this into 3 sections. We'll start with, we're going to draw this rectangle over here, 0.6 by 1.8, and we're going to extrude it. And if we look over here, it'll be 2.2. So we're going to draw this chunk here. So that'll be step 1. Step 2, we'll switch to blue. And then we're going to draw out these faces here. We're going to cut out these portions. Part 3 is going to be extruding this wall kind of this way. Part 4 will be bringing this out here, and then 5 will be making this cut. Then last but not least, we'll come in here, we'll do red again, and we're going to come in and cut this chunk out like so. So quite a bit of stuff going on, and we're not looking at it from a front view or a side view or a top view. We want to look at this from an isometric view to where we can see kind of all 3 at the same time. And at first glance, you're like, this isn't making any sense. There's no dimensions. We're missing some stuff. But it's all there. Everything's there that you'll need. So if you go ahead and take a screenshot, again, I will post this in the description if you want to download it as a PDF. But if you're the screenshot type, go ahead and take a screenshot right now, and we will jump into it. All right, now that we are in Onshape, let's go ahead and open up a new sketch. So I'm going to click the front plane and press Shift and S, and that'll start our new plane. I will press N to normalize and P to hide those planes. Next, what I want to do is start a rectangle. You can go center if you want. I'm just going to go from a corner. We're going to use that corner rectangle with the G key on the shortcut key. Go ahead and click, and from there I need to go over 0.6, and I need to go up 1.80, and we have our rectangle. So we start rotating this to the side, and I press Shift and E. I'm going to extrude that, and I actually want to go back that way. I don't know, just the way the drawing looks, I want to use that face the opposite way, and that needs to go back. If we look back at our drawing, I'll pull it up right here. We need to go up 2.2. Extrude that thing 2.2 inches. So we'll jump back into our part studio. Our other part studio, there we go. 2.2. And we are good to go. After that, we could draw up to here, so we're going to pull this shape. I know I said we kind of are going to do this in chunks, but I think if we make the whole shape and then start the cutouts, it's going to be a little bit easier. So let's go ahead and take this, and I'm going to need to make a rectangle now that is the same, shares the same corner, but only comes over 0.6 to the side, but then gets extruded 4. So let's do that. We'll go back in, and now I'm going to draw a sketch on this side. And then we will do a rectangle, so a corner rectangle using G. We'll come here, touch down there. It's going to give us that 1.8, but we need this to be 0.6, and we'll say OK. And now I can extrude that, and if we look back, we know we said it needs to be 4 inches all the way across. However, we have a thickness of 0.6 here that we got to take care of. So we can do it in 2 ways. We can do it as an offset, or we can just do a simple math problem, and I like doing the math. So I can say 4 minus 0.6, and it's going to give us that. If you wanted to, though, instead of doing any math, we could just say straight up, we could just make it 4, and we'll say accept. And if we go back into our sketch, instead of drawing it on this face right here, we could draw it on this face here. And it's going to be, since we mirrored it around, that rectangle is going to be this way, 0.6. We'll say accept. So now if we go back to our front plane, and we swap the directions, it's going to go 4 inches that way, including that, because it's starting from this point right here. So a couple of different things you can do to make that happen, but whatever works for you. So we have this chunk drawn minus those cutouts, and now we need to go 2.2 this way. So we're going to draw on this side a rectangle that is 0.4 by 0.18 from that side. So we'll go here, Shift and S to start another sketch on that side. We'll do a corner rectangle with the letter G. Come up here, and it needs to be 1.8 wide by 0.4. And we will extrude that. But we want to go the other direction, and at this point, this is where it's kind of cool. Instead of doing a blind, I'm going to say up to face, and I'm going to click that face there because we know it needs to align with one another. And we'll say accept. And if we look back at our drawing, we know that that's the same length because they only gave it to us one time in this drawing. So that's going to have to be how that dimension is derived. Next, we're going to start doing some cutouts. So we'll start with part 1. We'll do these cutouts here, and then we'll drop these things down. So it looks like we're going to need a rectangle that is 0.6 tall by 0.7 wide. Go up 0.8, and then have another one 0.7. So it almost looks like it's easier to just draw one rectangle and then have everything else based off of it. So we're going to come over here, start on this side, Shift and S on that face, and normalize. And I'm going to draw with a center point rectangle, but I don't want to actually click on the line. I kind of want to just hover up over above it, come down and touch, and we said it needs to be 0.7 wide, and I didn't really get a dimension for how tall there. The bottom one needs to be 0.6. So if we come in here, dimension 0.6, we're good. And then I need to do another one. So another center point rectangle, letter R, you can find it on the top. They need to have that same center point. We need to track to there. Like that. Still 0.7, but this time we didn't give that dimension. But the dimension we were given was from here to here needs to be 0.8. And you'll see it'll shrink that accordingly. So 0.8 between the two. And then now we need to tell it, hey, from that corner to here needs to be 0.5 away. So we can go I'm just going to move that out of the way. I keep running into that guy. Move to parent folder. So now from here, we're going to dimension this to this needs to be 0.5. And since everything is aligned with one another and constrained to one another, when we press enter, it'll shift everything over. And we know that it's fully defined and it's constrained to one another because everything, all our dimensions are black. Now we're going to go Shift and E. We're going to click remove. And again, we're going to go up to face and click that face there instead of doing any dimensions for how deep. Yes, I did give you the depth and we could type it in again, but I like to future-proof my drawings in a way to where I might change this thickness later, and that would change accordingly. So I don't want to have to go back in and change those dimensions. So if we look at this again from the ISO view, our part 1 is done. Now we need to click on this face and we're going to cut out some notches. So we're going to do Shift and S again and to normalize. And the way I like to do this one, I did a rectangle, corner rectangle from the top down, and another corner rectangle. And actually it's the math, if you go from the midpoint, it'll actually work for you. But this rectangle needs to be 1.6 wide by 0.5 tall. And this one needs to be 1. And oh my gosh, it broke. Well, it broke because when I first selected that point, I selected it based off of that midpoint. Well, I can't have this be 5 and this be a number other than 1 when I told it to be in the middle of it. So kind of backwards, back step a little bit. I'll show you one more time. If your workflow gets messed up, don't worry about it. Just kind of backtrack one step and figure out what happened. So 0.5 there, like I said, and 1.6 like so. Now from here I can go and say, hey, I want to track down this way, and this needs to be 1.2 wide by another 0.5 plus 0.5, but I don't know what that measurement is. Maybe I don't know how to do that math, but I only know that from here to here is supposed to be 0.5, so I will tell it 0.5. And now I'm going to extrude that chunk, but I'm going to remove it again. Now I could say up to next because the next wall is that wall there, so that's kind of cool. Another option you can do instead of up to face. Again, if you're trying to save yourself some clicks, that'll be the way to do it. Last but not least, we're going to come down here and we're going to make a cutout. Look at our print. A 1x1 square that is 0.4 from each side. So to me, I see this as a like a center point rectangle, and then we'll use some dimensions accordingly. So come in here, we're going to draw a sketch on this face, Shift S, and to normalize. And I don't know why, but I like looking at it with the word top. If you look up here, top has to be read the right way unless I'm doing some sort of rotational type thing. But for this, I don't know, for my mind, it has to be straight. So I'm going to do R for center point rectangle. And if we look really quick at this measurement, and we can do some simple mental math, 1 subtracted from 1.18 gives us, or 1.8 gives us 0.8, minus a 0.4 and a 0.4 on each side. That gives us down to nothing. So we know that they're centered, 0.4 on each side. So I could select this center point right here, and I know that didn't work for us on the last time, but this time it is. So if I line up with here and then go out, I can tell it 1 by 1. And then if I were to dimension this, you would see from this corner to here is 0.4, but it's a driven dimension, being while the number 1 is the driving dimension, and that's because we use that center line. Now I'm going to undo that, and show that again, but this time we're going to use a center point rectangle as well, but I'm not going to track from that center point. I'm just going to come up here and tell it to touch down at the bottom. We're going to say 1 by 1, enter, and this time I'm going to use the dimension and say, hey, from this side to this side needs to be 0.4, and you'll see now that's a driving dimension. That 0.4 is actually driving where that location is. If I do this now here and I try to tell that 0.4, that is always going to be driven because it's being driven by this dimension here. If I change this to 0.5, you'll see it's shifted that to 0.3 and so on. So we have our piece. Now we're going to extrude it. We're going to remove it, and we're going to say up to next. We'll say accept. And that is how you do that drawing. Now, if we look over at our piece right here, the question in the corner says, what is the mass in pounds if made out of ABS? So the units we've been using this whole time have been inches. So everything should be in inches. And then you're going to create it all by assigning a material. But before we do that, I want to kind of edit some stuff here. Let's go back to this. We'll change that to 1.75. We'll change this to 1.25. We'll change this to 1. And we'll change this to 0.25. Just so our measurements are off. Obviously, that's not the correct shape any longer. I don't want to give you the direct answer. I like you guys to kind of solve it and try to figure it out. But this is the next step. So I would right click on my part and click assign material. I'm going to come down here to this new pop-up window, and it's going to ask me for the library. I'm going to click my Onshape material library, and then I will search for ABS, and we're just going to use a regular plain old ABS. I don't need the M30 or the PC ABS, just a regular plain old ABS. Accept it. And when we're done, if I pull up the, there's a little weight bar here in the corner. You can't see. It says display mass properties. You click there, and it's going to bring up this window and say parts to measure. What do you want? So I'm going to click my part. It'll highlight it, and it'll come up with a mass, and it shows the mass now of 1.67. That is not the correct answer. So you would need to obviously go back and change the edits that I did. But our mass is 1.67 with a material selection of ABS. So that's going to do it for us on this print. I know it's kind of a crazy drawing, and that's kind of my hope with these Blueprint Bootcamps, is getting you guys kind of a little uncomfortable with some of these drawings and a little more comfortable at the end. You know, it should be like a workout. Should be harder. So if you guys are liking this, let me know down in the comments. If there's a specific type that you want done in a model, or just the way I do things. I know I had a comment last week about not knowing how I do things and where I come up with some stuff. So I try to keep the keyboard buttons, and I'll try to announce how I am doing what I'm doing with the shortcut keys. But remember that if you go through and you watch all my videos, they're kind of set up in a way as a course. So if you don't understand a specific topic, go back and watch that video, and there's plenty of information on how to do each thing. So that's going to do it for us. I will see you guys next week. Take care.